In this video, we will examine how to find the zeros of a quadratic function, and while we're at it, we'll also find the x-intercepts because they kind of go hand in hand with the zeros. And one more thing, let's not forget about the y-intercept. We will find the y-intercept as well. Okay, so you see we have our equation, y equals x squared plus 12x plus 32. And we have the graph, and we can see that we have labeled the points -8, 0, and -4, 0. So in this video, I'm going to show you how we arrived at those ordered pairs. So the first thing we want to do is we want to find the zeros of the function. So here we have a little definition. So if you have a function f of x, when f of x equals 0, then the input value x is what's called a zero of the function. So basically, the zero of a function is the x value that generates a y value of 0. Or in other words, I can say the zero of a function is an input value that generates an output value of 0. Basically, it's the x value that gives you a y value of 0. So when we're setting our f of x equal to 0, what you want to do in your function is you want to set the output variable equal to 0, okay? Because you're trying to work backwards and solve for the input variable. Now, when you find that f of x equals 0, when you find the x value that allows f of x to equal 0, then that becomes a point on your graph. So whatever input value you find, it's that input value paired with an output value of 0, and that becomes a point on the graph. And that will always be an x-intercept, because think about it. If the y-coordinate of an ordered pair is 0, then you're sitting on the x-axis and you must be an x-intercept. So again, notice in this ordered pair, the output is equal to 0, and we're trying to find the input value. So again, the zero of a function is the x value that generates an output value of 0. And then once you have that, you can easily find the x-intercepts. So there's subtle differences between the 0 and the x-intercepts, but we need to mention them. So I'm going to rewrite our equation in function form. So instead of y equals, I'm going to have f of x equals x squared plus 12x plus 32. But I do want to highlight here the colors in this image. So notice everywhere we see y, it's in purple. And in the ordered pairs, the output value is purple. So keep in mind that your y value is your output value. That's also your f of x value. So those are all in purple. And then everywhere we see x, it's in red. So those are the input values. So again, the red input values are the ones that generate the purple output value of 0. All right, so let's find the zero of this function. So again, I want to set f of x equal to 0. So I get 0 equals x squared plus 12x plus 32. And then by solving this equation, I'm figuring out what are the input values that are going to produce that output value of 0. So I will use my zero product property, and I will factor to x plus 4 and x plus 8. So hopefully you notice the 8 and the 4 in the graph. You might be wondering, well, why are they negative in the graph? Well, here's why, because of the zero product property. So I set the binomials x plus 4 and x plus 8 equal to 0. So I get the two linear equations, x plus 4 equals 0 and x plus 8 equals 0. So to solve the first equation, I subtract 4 from both sides. So we see that x equals -4. In the second equation, I will subtract -8 from both sides. I'm sorry, I will subtract 8, not subtract -8, because that would be adding 8. I will subtract 8 from both sides and get x equals -8. So I'm going to create a box over here that's going to give my final answers. So those two values are the zeros of my function. So the zeros are -4 and -8. Now, once we have those, we can easily find the x-intercepts. So that's where these ordered pairs came from. So what these zeros tell me that my input value of -8 gives me an output value of 0. So f of -8 equals 0. That corresponds with the ordered pair -8, 0. And the other input value, -4, gives me 0. So f of -4 in function notation equals 0. And that's where the other ordered pair comes from. So those are my x-intercepts. So now that I have the zeros, I can also say that the x-intercepts are -4, 0 and -8, 0. So notice how the zeros of the function are just integers, -4 and -8. But the x-intercepts are ordered pairs. -4, 0 is one ordered pair, and -8, 0 is the other ordered pair. Now, while we're finding intercepts, we don't want to forget about the y-intercept. But remember, in a y-intercept, we are trying to find the output value that is produced when the input value is 0. Because remember, a y-intercept is a point on your y-axis. So if you are an ordered pair sitting on your y-axis, your x value must be 0, or your input value must be 0. So to find the y-intercept, we just want to find f of 0. So I'm going to set up my skeleton here, and everywhere I see an empty set of parentheses, I'm going to insert a 0. So f of 0 equals 0 squared plus 12 times 0 plus 32. And after some simplifying, I get f of 0 equals 32. So when I input an input value of 0 for my x, I am generating an output value of 32, which gives me the ordered pair 0, 32. So the y-intercept is 0, 32. Again, notice how that y-intercept is written as an ordered pair. It tells me when the input is 0, the output is 32. Now, we don't see 0, 32 on the graph in this particular video because my y-axis would have to extend much higher, but you can imagine as that parabola continues to move, as the y values continue to increase on that parabola, eventually it would cross the y-axis at 0, 32. I hope you enjoyed this video on zeros and intercepts.